Hello, my name is Christina. So for this problem, we are given a function and we are asked to graph it by hand and then verify it with a graphing utility. So some things to help us in this process. We're going to check for what are the intercepts, are there vertical asymptotes, are there horizontal asymptotes, are there any holes. We'll go piece by piece dealing with those different categories. So first, checking for intercepts. The best way I found to figure out an intercept is we will plug in as if x equals 0. Then we'll do the same thing as if y equals 0. And that'll give us two very important points, our x-intercept and our y-intercept. So we can start, we will make x equals 0. Remember that anytime I have an f of x, or a c of x, or a d of x, or whatever they give us over here, that's interchangeable with the variable y. So what that means is I can rewrite this as y equals, and again I'm making x 0 in this case. So this becomes plus 2 times 0 all over 1 plus 0. I go ahead and simplify. 2 times 0 is 0. I wind up with a 5 on the top and a 1 on the bottom, giving me y equals 5. What that tells me is that it gives me a point. I know that when x equals 0, y equals 5. Great, so I have one of my intercepts. Now I can do the same thing. That time I made x equal to 0, now I want to make y equal to 0 and see what I wind up with. So again, we'll make y equal to 0, and then I'm just rewriting the rest of the equation. 5 plus 2x on the top, 1 plus x on the bottom. So now I want to solve for x. So I'm going to start by multiplying both sides of the equation by 1 plus x. But notice that what happens is 0 times anything is 0. So it effectively eliminates this 1 plus x. I can rewrite this as just 0 equals 5 plus 2x. And again, my goal is to get x by itself, so I will go ahead and subtract 5 from both sides. I wind up with negative 5 equals 2x. I'll divide both sides of that equation by 2. I wind up with x equals negative 5 halves. So this is important because I've given myself another point. I know that when y is equal to 0, that my x is negative 5 over 2. So I've checked for intercepts. Now I want to check for vertical asymptotes. I do this by going back to my original function. I'm going to look closely at the denominator. I know that I can never have 0 in the denominator. So if 1 plus x is equal to 0, I can go ahead and solve this new equation for x. That'll tell me where is my vertical asymptote. I subtract 1 from both sides. X equals negative 1. So this is my vertical asymptote. Vertical asymptote at x equals negative 1. And if I come to my graph, what does that mean? That means that at the point where x equals negative 1, of a vertical asymptote, it means that the function will never actually touch that line, although it'll get awfully close. So I know my vertical asymptote. Next, I'm going to check for horizontal asymptotes. Now for horizontal asymptotes, I suggest memorizing a couple basic rules, which I have put down here on the corner. So we've got horizontal asymptotes. What I'm doing is I'm comparing the exponents in the numerator and denominator of my original function. I went ahead and I wrote out the rules here. I suggest pausing the video and maybe copying those notes down because you will want to memorize that. If I look at my function in this particular problem, the exponent on the numerator's x is simply just 1. Same with on the denominator. The exponent of that x is also 1, which means that my exponent on the top is equal to my exponent on the bottom, which means n equals m in this case. And if I look at my little guide, it tells me that if n equals m, the horizontal asymptote is the line y equals a over b, which means y will equal the coefficient of the top x over the coefficient of the bottom. My coefficient of the top x, on my numerator, it's a 2, and on the bottom, it's a 1, which tells me that my horizontal asymptote is the line y equals 2. So then what does that mean in terms of my graph? Well, that means if I go to y equals positive 2, right about here, I've got a horizontal asymptote. That's a place where my function will get awfully close to that line, but it'll never actually touch it. So I go ahead and just kind of sketch that out. Great. So we checked for the intercepts, vertical asymptotes. We just checked for horizontal asymptotes. Now I want to check for holes. Now in this problem, I don't have any holes. If I had, it actually would have become apparent when I was looking for my vertical asymptote. The difference between a vertical asymptote and a hole is that a vertical asymptote is not removable, whereas a hole is. For example, I might have had a problem where, let's pretend, let me do an example problem. If I would have wound up with x minus 2 on the top, so here, for example, if I would have looked at this denominator, I would have come to the conclusion that x cannot equal 2, because that will give me a 0 in the denominator, which I know is not allowed. However, after I've factored this numerator and denominator, I will also notice that I can cancel out the x minus 2 in the top and the x minus 2 in the bottom. That's an indicator that we call this removable, meaning that this kind of limitation or this error where we're not allowed to have 0 in the denominator is removable. So by definition, we call that a hole instead of an asymptote. The difference graphically between an asymptote and a hole is that an asymptote is a line. We see our lines on this graph here. That's a line that the function is going to approach but never touch, whereas a hole is just like it sounds, a hole on the graph. So I might have a hole at x equals 1, where the graph is complete except for at that one spot, x equals 1, where I have an open circle to represent that there is no point at x equals 1 on that graph. So now I've checked for intercepts, my asymptotes, and holes. I can go ahead and try to graph this out by hand. I'm going to plug in my intercepts that I've calculated. I have the point 0, 5. 1, 2, 3, 4, 5 is about here. And I have the point negative 5 over 2, 0. Negative 5 over 2 is about negative 2.5. Not about, it's exactly negative 2.5. Negative 2.5, 0. Great. Okay, so now that I've figured out my asymptotes and I have my intercepts, I want to go ahead and just sketch this in as best I can. I know that my function is going to approach that line but never touch it, and likewise approach this line but never touch it. And then on the flip side, I know that this is my intercept, and I also know that I'm going to approach this asymptote but never touch it, and I'm also going to approach this asymptote but never touch it. So there I have sketched out the graph by hand, but now they also would like us to use our graphing utility to confirm this. So I go ahead and I find my y equals, and I'm going to plug in my original function. I want to make sure that I get into the habit of always using parentheses to separate the numerator of my equation and the denominator. I go ahead and plug it in, I press graph, and you'll notice that the image on the graphing utility matches up with what we were able to sketch out by hand. And that is how we do this problem.